use this data here, and these are paths of tornadoes that all happened. I know this is long before any of you guys were born, but all these tornadoes hit in Oklahoma on the same day. They had 59 tornadoes, and these are the lengths of the tornado, just as part of our data.
That sucks.
I know it's a lot. Okay.
Wait, that's real?
No, I made it up very elaborately to put it on the notes. Yes, it's real. Okay. That would be really shady if I did something like that. Okay, and weird. Why would I do that? Okay. All right, so instead of organizing this, least to greatest and doing the median, the mean, and all that, you can have your calculator help you do this. If you don't have a calculator, I will show you guys later. You can also do this on Desmos. So the graphing calculator is probably the easier way to do it, though. What you're going to do is you're going to find a button, and let me see if I can get it on the screen here. There is a button. It's kind of near the alpha button and the arrow keys here. It says Stat. So you're just going to hit that button real quick, and it's going to bring up this menu. And you want to just go ahead, after you hit the Stat button, we do want the first option. You're going to edit, and you're going to go ahead and type in the data. So go ahead, hit enter. Okay, now mine has some information in here. If yours does, we might want to go ahead and get rid of that. So I'm not going to put this as part of the directions, but you don't want to use the delete key. So I'm just going to arrow over to mine. I'm going to use the arrow key. I'm just going to go to the top where it says L1, that stands for list 1. You want to hit the clear button that is right under the arrow keys, and then hit enter, and it'll take everything, any data that might be in the column, it'll take it out. And then if you have stuff in the other columns, you can get rid of that too. Just arrow up to the top, hit clear, hit enter, and then it'll get rid of any of the data. Does anybody's calculator not start with L1? Like, does anybody missing a list or anything? Okay, I just want to make sure. If you get rid of one of the lists, let me know. I will tell you how to do that. Now, what you're going to do, L1 stands for list 1. You're just going to type your data, and you have to hit enter in between each. So I'm just going to type the lengths of these tornadoes. So like I'm going to hit 6, hit enter, 9, hit enter, and just keep going down. And just kind of, I try to watch as I go to make sure it matches up with the data that's on the note paper here. Just enter after each one. And even when you get to the very end, the last one is 2, you have to hit enter after you type the 2 to make sure it's in the list. All right, now, once you're there, once you have all your data in, you're going to hit that Stat button again, and it's going to take you back to that menu we first looked at. But this time, you're going to arrow over to the menu across the top, just using the arrow keys that says Calc. All right? And what you want under this Calc menu is just to go ahead and hit enter. And that first option, it stands for one variable statistics. We just have one set of variables there. So just hit enter. And now this is going to depend on your calculator, but it might just go right to it if you have an 83. If you have this calculator, it should be list 1 because that's where we type the data. If you need to change that, you hit second, and then the 1, 2, 3 keys, those have the lists, but we type the data in list 1, so I want to do that. If you have the screen, just keep hitting enter, and then it will show up. And then I'm just going to do like a little explanation of some of this stuff. So remember I told you guys yesterday the little symbol for the mean, they call it X bar. So that's actually literally the first thing they put in the data set. So the mean length of all these tornadoes, their path of destruction, I'm just going to go ahead and write the whole number that they have there, 12.8125. So over, like, close to 13 miles was the average length of the tornado. Now, the next entire group of things you're not going to need until you get kind of down to the bottom here and you can scroll down just using the arrow keys. The 5-number summary are the last 5 things at that. We'll talk about what some of those other weird symbols mean in a couple of days, but the N is just the number of data items. So we must have 16 tornadoes here. The minimum length was 1. The first quartile just says Q1, 6.5. The median, 8.5. The upper quartile or quartile 3 is 15. The maximum is 39. Now, the only 2 things that we really went through how to find yesterday that will not be displayed on the screen, these 2, the range and the interquartile range. The calculator, I'm just going to say that's not displayed. You actually have to figure those out. But you can do that. I mean, you've got the data right in front of you in terms of the range. It's just the biggest minus the smallest. So the range would just be 39 minus 1. So the range length of these different tornadoes would be 38. And the interquartile range, remember, that's whatever Q3 is minus whatever Q1 is. So for this particular set, it's just 8.5 minus 6.5. So the interquartile range is just going to be 2. Okay, now. Oh, shoot, I looked at the median. I'm sorry. What'd you guys get for that? 8.5. I'm sorry, I screwed that up. I wrote down the median number. All right. I think my range is right, I hope. All right. Sorry, I haven't drank all my coffee yet this morning. Okay, now, if you guys look at this list, like when you think about when you typed it, we're going to talk about outliers today. So an outlier, I just wrote the definition for you. It's a data value, or it could be more than one, maybe not just one, that is substantially different from the rest of the data set. So if you had to look at that data set with those different lengths of those tornadoes, do you think you have any outliers in there? Like, are there any that are just like way different from all the others? What do you think? Yes, and that is a very good guess. So there are a couple, and she actually gave me both of the outliers for this data set, but there is a technical way that you can figure this out. And so I'm going to give you these little formulas here real quick, and we would give you guys this on the test at the end of this unit, so you don't have to memorize this. But what we call the lower bound, any number below what we would determine that you do your Q1, whatever that is, minus 1.5, this is a formula, times the interquartile range. Any number below that, whatever that value is considered an outlier on the lower end. So we call this a lower bound or a lower fence. Sometimes books will refer to it as a fence. I usually call it a bound. But anything below that, on the upper end of your data, it's any number above. Now this formula is just slightly different. This is your third quartile plus 1.5 times the interquartile range. And those are the formulas for finding outliers. Now, Kai was exactly right. Those two, the 37 and the 39, are going to fall into these categories. Don't always assume that, though, because sometimes that it looks like it might be an outlier, but it won't actually fit this little formula. So let's just calculate this for our little data set above. So my lower bound, our Q1, and let me make sure I copy the right number, is 6.5 minus, 1.5 times our interquartile range, which was 8.5. Now, sometimes, and this is going to be the case here, that number might actually be negative, and obviously none of the data values were negative here, but I'll just show you so you know what the lower bound would be. 1.5 times 8.5 real quick here. This is negative 6.25. So there's no data value that's below that, so you don't have any outliers on the lower end. The upper bound would be your Q3, which is 15, don't write it wrong like I did, and then plus 1.5 times our interquartile range, which is 8.5. I'm just plugging this in. So 15 plus 1.5 times 8.5. This is 27.75. So if you look at your list there, we didn't have any negative values, so you don't have any outliers on the lower end. But on the upper end, 39 is above that, and so is the 37. So there's no others that are bigger than the upper fence or upper bound. So the outliers in this data set would be 37 and 39. Okay. Now, I'm going to have you guys compare what removing an outlier would do to the data set. So I'm going to actually show you how to do this real quick. So if you remove an outlier, so if I remove those two numbers, and I'm just going to recalculate, this will give you some good practice with what we were doing at the top. I'm just going to go back into that stat menu real quick, and we're going to edit the data because we're going to remove those two outliers. Just hit enter. And then I'm going to get rid of the 37 and the 39. So just arrow down to the 37. And then there's a little key that's right by the arrows that says DEL. That stands for delete. So I'm just going to delete that, the 37. And then I'm going to delete the 39. All right. And then I'm just going to go back to get the new stats. So I'm going to hit the stat button again. Arrow over to the calculate menu. And you want that first thing, that one variable statistics, that just gives you statistics for that one data set. And just keep hitting enter until it shows up. Now, the mean, if I remove the outliers, is going to change. So now my mean, sorry, I got this kind of spaced weird. This would be, I'm going to just go a couple decimal places, like 9.214, maybe 3 decimal places. And then just use the arrow keys. The bottom of the screen will give you that 5-number summary. So the minimum is still the same because we didn't remove any, there were no outliers on the lower end. But these are just shifted just a teeny tiny bit. So the first quartile is 6, the median is 8, the third quartile is 13. And now, once we remove the outliers, the maximum is 22. So what I'm going to do is I'm just going to show you guys the difference in the spread of the data and how it looks on a number line. So I'm going to say this first one I will do with, and then the second one we'll do without. So we're just going to use the data that we have. This will be without your outliers on this one. Okay, however you want to draw this. So with all the data from the original problem at the top, the minimum, let me see here. Oh, this number line actually goes by ones. So the minimum length of the original data set was 1. And we'll just kind of have to estimate if it's not a nice number. So our Q1 is at 6.5. So I'm just going to draw a little vertical line kind of best I can between the 6 and the 7. Our median, or Q2, is at 8.5. So I'm just going to do my best to come between the 8 and the 9. And then our Q3 is at 15. And then our maximum with the outliers in there is all the way down there at 39. So I'm just going to turn these guys into a box, just make it into a little rectangle. And then the whiskers, just like a little line segment out to where you have your minimum and maximum. So you guys can see that most of these tornadoes were under 15 miles in terms of the path with the outliers in there. If I remove that, you're going to see how this will shift your data. So without the outliers, the minimum is still the same. It's at 1. But now your first quartile's right on 6. Your median is right on 8. And your third quartile moves back a little bit to 13. And your maximum is at 22. And so you can see when I remove the outliers, the data is not nearly spread out as much as it was. So removing outliers can really condense and give you some better information about data if you've collected it. Is anybody having a question? Okay. Now, let me flip over to the back here real quick. So we're going to do something just a tiny bit different on the back. These are percentiles. So we did quartiles yesterday. We're going to do percentiles today. And you guys have maybe seen these. You can calculate them actually for yourself for your class rank and things like that. So I'll show you how to do that. But percentile is going to be some number from 0 to 100. Some number from 0 to 100, and you can associate with a value that is in a data set. Percentile shows the percent is that next open spot of the data that are less than or equal to wherever you're at in your data set. Okay, so just a little tiny example. So it says if you have a score or a height or something like that, and it's at the 90th percentile, that means that 90% of the data is less than that. So we'll get into how to calculate this here in a second. So what you're going to take, you're going to write your percent as a decimal. If you have a given percentile, you're going to calculate percent as a decimal though. You're going to multiply that by the number of data in the set of data that you have. So you have to count up how many data pieces you have. And that will give you the place, or sometimes they'll call this the position that that data value is in. And I'm going to make a little note here. This is really important. You always round down. If you had if I have 30.9, you round that down to 30. So it's weird, but the rounding on this, no matter what the decimal is, you always round down. I could have 40.9999. You have to round that down to 40 if that happens. Okay, now the one annoying thing about this is you do have to number the data. So I have test scores for 25 people. They're in order from least to greatest, so I don't have to do anything with that. But I have to figure out where each is in that set. So I'm just going to number these real quick. So the first person is a 43. And then I'm just going to put a little number under each, 1, 2, 3, 4, 5, all the way up. The last person should be 25. Sorry, I probably should have spaced those out a little bit better. So if you're going to calculate the 90th percentile, so this person got a better grade than 90% of the class, what you're going to do if you want the 90th percentile, you just write this as 0.9, and then you're going to multiply it by the number of items in your data set. So we've got 25 people's test scores here. So I'm going to do 9 times 25. Or sorry, 0.9 times 25. And I'm just going to show you this decimal here. So this is 22.5. Now, if we were normally rounding this, you would round this up, right? Most people would go, okay, it's a 0.5, we go up. Whenever you're doing percentiles, you always round down. So I want to find the 22nd position. And that score is better than 90% of the class. So I'm finding the 22nd position. So if you just come over here, just look, 22nd position, my answer to the actual question would be that 96 is the 90th percentile. So the person that got the 96 got better than 90% of the class. If I were to do the 20th percentile, it's just 20 percentile, you do 0.2 times your number of data values to find your position. So 0.2 times 25, and you guys can see on my screen, that's an actual nice number. I'm not rounding anything. So I want whatever number is in the 5th spot. So the 5th spot is the 62. So whoever got the 62 got a better grade than 20% of the people in the class. And then the 50th percentile, I'll do one more. So I just do 0.5 times 25 people in this class, and you're going to get 12.5. And I know it's weird, but no matter what, you have to round down. So you want the 12th position here to figure this question out. So I'm just going to go back here. Who's ever in the 12th position, they did better. than 50% of the class. So that score is the 72. So if you're calculating a percentile, you're finding the value where that person scored better than whatever the percentile. So 90th better than 90%, 20th better than 20%, 50th better than 50% of the class. Now the backwards version of this, how to determine the percentile. So if I give you somebody's score, which I'll go back and move that so you guys can see, what you want to do is take the place or position that data value is in, and you're going to divide that by the number in the data set. For our little example here, that's going to be 25. And then to get the percentile, you have to take that fraction and multiply it by 100. Okay, now, this is tricky, so this will give you one of the test scores that you're going to have. So the tricky part of this is this part here, and I put this as separate so we can write it down. If the data value appears more than once, so let me come up to the data just really quickly. So like I have an 88 that appears twice, or I have a 99. There's a couple of these scores that appear more than once. If that happens, you want to choose the data value farthest to the right. So you're looking at that list. They're all in order from least to greatest. If it appears twice, whatever number you're going to get, you're going to pick the one that's farthest to the right. All right, so we're going to calculate these percentiles. So if you got a 70, let me move this so you guys can see the little data here. Hopefully this is big enough. Okay, so what percentile is a score of 70? See if I can pull it up so we can see it on the screen. All right, so here's the 70. That is in position 10. Let me grab a different color. Here's the 70. So you would take 10 out of the total number, which is 25 people. You multiply that by 100, and that'll tell you the percentile. So I'm just doing 10 out of 25, multiply that by 100, and I got 40. So this is the 40th percentile. If I want to know, okay, where does 93 fall? So here's a 93, that's in position 20. So I need the position there. So this would be 20 out of 25. And I'm going to multiply that by 100 to get the percentile. And you're going to get 80 if you do that. So this is the 80th percentile. If I pick 88s, okay, so notice in the list there's two 88s. So you pick the one that is farthest to the right. So that would be position 18. There's another one in position 17, but to do this accurately, pick the one farthest to the right. So that would be the position that you want. 18 out of 25. And then you're just going to multiply that by 100. 72, I heard somebody say it. So this would be the 72nd percentile. And just to practice one more here, I'm going to find 62. Okay, now again, 62 appears twice, and we can match this up because we did this. This should be the which one? This was the 20th percentile. So this should match. So I'm just going to go backwards from this. You're going to pick the one in the farthest position, so that was the 5. So this would be 5 out of 25. Multiply that by 100, and you should get 0.2, or sorry, so you get 20 when you do that. So that matches up. That's the 20th percentile. Is anybody having a question?